Welcome to the Mechanics of Materials lab. Today we are going to demonstrate the torsion test. The torsion test we are going to do in a new machine, WP510. It has a start and off button. Let's turn it on. Once the machine is turned on, you can see there is a display coming here. Now in the display you can see two data. First we are getting the angle of twist, and the second is the amount of torque needed for that. There is a cable that goes to the computer. We can directly get the data from the computer also when the test is running. We are going to do a torsion test of aluminum sample. Now this is the sample that we are going to test today, and you can see it has a hexagonal head in the left side and on the right side. So before running the test, we want to measure the diameter of the sample. Let's measure the diameter what we get. 8.97 millimeter. It's better to take measurements in couple of locations so you can see the variations. The next step would be to set the specimen in the testing chamber. Now you can take it off, and in terms of fixture we have two fixtures. One end is fixed and the other end would be rotating. So this end can move back and forth depending on our sample size. This is the open position, so now we can move it back and forth. If this is closed, both these two are closed, it will tighten the setup and we can try to put our sample. Try to push it forward and try to fit it in the end that is moving. If this doesn't fit, we want to rotate and keep it in such a way so that this two matches and goes inside. Alright, so the sample is fixed in between the fixtures. Now we want to close this end. We are closing this. We also want to see when the twist is happening, the torque is applied, how the twist is being visible on the sample. So let's put a straight line mark on the sample. Next, let's close this chamber. We are now ready for the test. So either way we can get the data from the display, or the same data it can come to the computer and we can get it from there. It will save as a text file. We'll show the procedures as well. So we have this WP5XO. This is the software needed for the torsion test. Let's open the software, and here we have the x-axis is showing the angle of twist in degrees, and the y-axis showing the torque. Few things we can do before running the test. We can set at what test rate we want to do it. So that thing, let's come back to the machine window, and on the speed here it shows 50 degrees per minute. There are four options: 50 degrees per minute, 100, 200, 500. Let's do this test at 200 degrees per minute. Run the test. So here this play button, if I hit play, it will start running test. So let's hit play, and you can see the torque is increasing. At the same time the angle of twist is also going high. Let's look into the display. We are getting the same linear zone, and it has already yielded the test rate that we set. Based on that, it has already yielded. Now we're into the plasticity. So what you can see here, the torque value remains pretty much in the 40 Newton meter range, and it's not changing that much. We're having a very high amount of angle of twist, the change in the angle. Let's come back and see that straight line bar. I don't know whether we can show it or not. That straight line, it has started twisting. Okay, so when you do the test in your lab during the class time, you should come here and you can physically check that the angle of twist is acting. Okay, the real data you can always get from the computer for a visual understanding. So you can see we are having almost 280 degrees angle of twist with roughly 41 Newton meter torque. So we'll keep doing the test until it breaks. We also want to show you the fracture surface, and later on in your lab handout you can see how to find the shear modulus and the yield torque. Okay, so the sample is broken. Okay, you can see the sample is broken. The next, we want to see the fracture surface and where it broke. Let's take the sample back. So move it anti-clockwise. The right one you should move to the, again, anti-clockwise. Then we can bring it a little bit back. And let's take the sample out. You can see that straight line mark has covered about 360 degrees. Right now, right, this is very twisted, but we had a very straight line. And let's look into the fracture surface, if you can see or not. So this type of surface is purely because of the shear. This is very different than what we tested in the tension test. So when you do the lab, you'd be getting the data from the computer. You just get the idea of how this fracture is happening. Then use the data to find the shear modulus, to find the yield torque. All these procedures should be in your lab handout. Let's go back to the computer and I'll show you how to save the data so that we can use for our calculations. Hit this save button. It will take some time, and then you just put a file name. So let's say this is our aluminum T6 6061, and it will save it as a DAT file, which you can convert into a text file or Excel file. Just save it, just put the name again. You can put some comments if you want, and just hit save. Okay, that's it, and your data would be there in the blackboard.